So this is a very interesting problem and difficult also for many of you. Two plane mirrors M1 and M2 are inclined at 30 degree to the vertical. A point object O is placed symmetrically between them at a particular distance 8 centimeter from each mirror. So at least the object is symmetric, okay? Little bit easier. The distance of the object from second image formed in M1 is n root 12, then n is. So you have to find the distance of second image in formed in M1. That means the image of M2 will act like an object for M1, and there will be an image, second image formed in M1, and you have to find the distance of that image from O. So these kind of questions you must have done where the mirrors were parallel, right? You might remember if the mirrors were parallel, the number of images will be infinite, and similar questions you might have done when the mirror was parallel. But this becomes difficult because the mirrors are not parallel, they are inclined at an angle 30 degree with the vertical. So let's first remember how we used to solve the questions for parallel mirrors. There was a technique there, so let's just revise that technique and then we can apply the same technique to this question also. One method is the basic approach, other is the technique, and other is the shortcut formula. So I will tell you the technique and the shortcut formula if you want. That was for plane, the parallel mirror. So let's say there are two mirrors, okay, parallel to each other. These kind of cases you must have seen. Let's say this is mirror M2, this is mirror M1, and object is kept somewhere here. This distance is, let's say, 1 centimeter or whatever, and this is, let's say, 3. Okay, so this is the object kept. Now image M2. Now what the technique is, you can, if you want to find the images, all the images in M2, okay, so the technique is just draw the reflection of M1 in M2. So you will draw the reflection of M1, you will get something like this. This is the technique. Draw the reflection of M1 in M2. So this is reflection of M1 in M2. Then draw the reflection of M2 in M1. So draw the reflection of M2 in M1. Then draw the reflection of M1 in M2 and so on. So this is the way you can just solve it like this. Now just see, now the question is very simple. Object distance is equal to image distance. So this is the mirror M2 and we have to find the distance of all the images from M2. So now the first image, this object distance is 1. So the first image, direct image, will be here, formed at 1 centimeter. Now this will be 3. So second image, since the object is at 3, second image will be formed here at a distance of 3. Then again this will be 1. Then there will be another image, I3, at a distance of 1. This will be 3, and so on. Again I3 will form a image here at a distance of 3, and this will be I4. So this is how quickly you can get the position of images. So you have to draw the reflections, okay? So what would the answer be? If we are measuring distances from M2, first distance is obviously 1. What about second image distance? Second image distance is this much. 1 plus 3 is 4, and 4 plus 3 is 7. So 7. What about the third image? Third image is somewhere here. So 4 plus 4, 8 plus 1. 8 plus 1 is 9, and so forth, right? So this is one way. Draw the reflections and get the location of images very easily from M2. Similarly, you can do for M1 also. Just draw it on the left side. Or in these parallel cases, since these are very common, you can just remember the shortcut also. The formula, shortcut formula is, let's say if this is A and this is B, okay, and total distance A plus B is, let's say, D. So first image you can directly see, if the object is at 1 centimeter, image will also be at 1 centimeter. So that means if object is at B, image is also at B. So distances of image first will be B. Then second will be very simple, just you can remember is, once you have taken B, then just take D plus A. D is the total distance between them. Then it will be 2D, now again B. Then keep on increasing. Now 3D, now again A. Next will be 4D plus B, and so on. So this way you can get the results directly. First B, then D plus A, then 2D plus B, then 3D plus A, 4D plus B, 5D plus A, 6D plus B, and so on. Once B, then A, then B, then A, and keep on adding D every time. So let's see, first case is B is 1, D is equal to 4, and A is equal to 3. So 4 plus 3 is 7. Then D is equal to 4, so 8. 8 plus 1 is 9. Then 3D, so D is equal to 4, so 12 plus A, 12 plus 3 is 15. Then 4D, 4 into 4 is 16, 16 plus 1 is 17, and so forth, right? So this is how you solve the questions when the mirrors were parallel. So this is a very important concept you should know. So the technique was draw the reflections of mirror so that it becomes little easier. Same technique you can also apply in this one. Otherwise this question, otherwise also you can solve by basic method, but that will be little complicated. But if you apply the method which I am saying, it will still seem difficult, but at least it's relatively easier. So let's solve this question now, okay? Understood? So two plane mirrors M1 and M2 are inclined at 30 degree with the vertical. A point object is placed symmetrically between them at a perpendicular distance 8 centimeter. The distance of object from the second image formed in M1. So we have to find the distance of second image formed in M1. So we will draw a reflection of M2 in M1. So I will just do that for you and then we will take a new slide for this. So see, I'll just give you an idea. This is M1, just connect it, does not matter, right? You can extend the mirror. So this angle will be 60 degree, 30 and 30 will become 60. And you have to draw the reflection of, this is M1, this is M2. So you have to draw the reflection of M2 in M1. Okay, so the reflection of M2 and M1 will be like this. M2 dash. This will also be 60 degree. We are drawing the reflection of M2 in M1. So this is M1. So you are drawn the reflection of M2 dash in the mirror. Okay. So angle should be same, 30 degree, sorry, 60 degree. Okay, 60 degree. And this, you also know that this angle is 30. So technically this is 90 and it becomes flat. So this is the image of M2 in M1. Okay, image of M2 in M1. You can also think it like this. Just extend M1. Image of this part will be here. And image of next part will be somewhere here. And this will be the reflection, right? Object distance is equal to image distance. So image of M2 in M1, you must know how to draw it. It's just a mirror image kind of thing. So let's just take the new slide. Okay. So this is M1. This is M2 and this is a reflection of M2. Now data is given little easy. So this is a reflection of M2. This is M2 and this is M1. Object is symmetric at a perpendicular distance of 8, right? This angle is 30 degree. Let's take this as origin. Let's take this distance as x. So the coordinate will be 0, minus x, y axis, right? So this is mirror M2. This is mirror M1. So in mirror M1, we have drawn the reflection of M2. So everyone should be very confident in drawing the reflection of M2 in mirror M1. Okay. What about the angles? So this angle, full angle is 60 degree. Now just draw the images. So this is object. One image in M1, direct image is like this. Direct image will be formed here, I1. This is at 8 also. And then this image, you will get another image here. This will be I2. That's how you solve it. Okay, so first direct image, then in the reflection of the mirror, draw image, that is the I2, second image. So we have to find the coordinate of I2 now. So how to find the coordinate? Again, it's use symmetry. This angle is 30 degree. So that means this angle is also 30 degree. Total was 60. That means this angle is also 30. So that means this angle is also 30 degree. As simple as that. If this distance is x, this distance is also x, and this distance is also x. Right, because of the mirror symmetry. Now if this distance is x, what is the coordinate of I2? It will be minus x cos 30 comma x sin 30. So this is geometrical. So if your geometry is weak, you will find very difficult to solve this problem. So this is I1, this is I2, and this was the object. Okay, it's just symmetric diagrams are drawn, not a very big deal. If you solve it 2-3 times, you will get it for sure. So now you have the coordinate of I2, you have the coordinate of object. And what is x? This is 8 and this is 30. So for x, you can say x sine 30 is equal to 8. Okay, in this triangle you can see x sine 30 is equal to 8. So that means x is equal to 16. So the coordinates are, one of the coordinate is 0, minus 16, and other coordinate will be minus x cos 30. So minus 16 root 3 by 2. So minus 8 root 3, comma x sine 30, that means 8. So these are the coordinates. Now distance formula can be applied and you can directly know the distance. Distance is under root x2 minus x1 square. So this will be 8 root 3 square plus 8 minus of minus 16 is 24 square. 8 we can take common. So 8 will be common. Then you will have root 3 square is 3 and plus 8 3 is 24. 3 square is 9. 9 plus 3 is 12. So this is 8 root 12. And in the question it was n root 12. So that means the value of n is equal to 8. Understood? So this is how we use the concept of reflection of a mirror inside a mirror to solve questions like this. And the concept of 360 by theta, you have studied a concept where number of images was 360 by theta and then minus 1 and plus 1, minus 1 if it is even and all. So that concept is also based on this reflection of a mirror in a mirror and in a mirror. So if you knew that concept, you could have applied it here also. So just go through this problem once, you will find it easy. Just take the reflection of the mirror first and then keep on drawing the images, and then the coordinate will be easier to find and you can get the answer. All right, so this is really a difficult problem, and if your mathematics is strong, this will look easy. Otherwise, you might find it little difficult. All right, so bye bye, all the best.